I've really been learning a lot about statistics and have started to see how it relates to my everyday life.
That's interesting. That has been happening for me too. For example, the other day I was talking with my sister about the weather in Seattle. Did you know that it fluctuates more than people think?
Really? When I think of Seattle, I assume it's always raining there.
Well, it turns out that the standard deviation for the number of rainy days per year is large.
So, what does that tell you?
A large standard deviation suggests that some years it rains a lot and some years it doesn't. It depends on the year. I think she understood, but then she asked me if this year was a strange year for Seattle or not. She says that it seems like it hasn't been raining too much this year.
Well, I guess we can compare how many days it's been raining this year against the average number of days it rains per year.
But what if it has only rained one less day than the mean? Would we then conclude that it has been a strangely dry year? How many days would it take to seem very different from average?
I think there may be a way to figure that out using the standard deviation. We should use the standard deviation as a tool to measure how different this year's rainfall is from the mean.
Oh, that would make sense. If the standard deviation was small, then even a small difference from the mean would suggest that this is a pretty different year. But since the standard deviation is large, it would take a pretty large difference for us to conclude that this year is very different from the other years.
Yes, so instead of measuring how different this year is from other years in rainy days, we can measure it in standard deviations.
Whoa, you lost me there. What do you mean measure it in standard deviations?
Well, let's say it rained 80 days this year, but on average it rains 86 days in a year. If we thought about the difference in unit days, that would be 6. But what we need to know is 6 days a big difference, so instead of measuring that difference in days, we should measure it in terms of standard deviation.
That sounds a lot like calculating z-scores, because the z-score tells you how many standard deviations a score is from the mean.
Yes, let's look at the formula for z-score and see if we can make sense of it in this new way. This is the formula for z-score.
It seems that here you have the distance between the score and the mean.
Yes, but you have to remember that this difference is in terms of the measured unit. In this case, days. It's not in terms of standard deviations yet.
Oh, so that is why you divide by the standard deviation. That's sort of like telling you how many of standard deviations fit inside this distance. It's almost like we're using the standard deviation like a new kind of ruler.
Exactly. In statistics, that's how important variability is. We want to use it as a new kind of ruler.
So let me see if I get this straight. The z-score tells you how many standard deviations a score is from the mean. So if the z-score is 1, that means the score is exactly 1 standard deviation above the mean. Can the z-score be negative?
Sure, why not? If the score is below the mean, the z-score will be negative. So in your Seattle situation, if there are fewer rainy days than normal, the z-score will be negative. Also, if you know that the number of rainy days per year are normally distributed, you can use z-scores to figure out exactly how rare this year is.
Okay, I'll draw a normal distribution just to try this out.
We can even use a Seattle situation as an example. Let's say the average number of rainy days is 86, but the standard deviation is 15. How would you label it in days?
Like this?
Yeah, now how would you label it with standard deviations?
It looks like I'm just relabeling the graph.
You're right, we're just making it easier to see and talk about standard deviation.
This clearly shows a new way of measuring distance, and I guess this can work with any example, not just examples that have to do with days or even time. If my score on the exam was 2 standard deviations above the mean, and exam scores are normally distributed, that's way better than most people. Or if a house price is 2 standard deviations below the mean, and housing prices are normally distributed, that's a super cheap house.
Awesome.